it proved that the product of two odd numbers is always odd. Okay, so the product means to times, yeah? So, you know, for instance, two odd numbers, 3 and say 7, 21, okay? Well, the product of the two odd numbers there is odd. 5 times 9, 45. Okay, yeah, it's odd. Okay, so we've done it here for two cases, but there's an infinite amount of them. So see if we can do it algebraically. So the first odd we're going to consider will be, say, 2k plus 1. Yeah, for a constant k. The second odd number we'll think of as 2p plus 1. Okay, you can use any letters you want, right? As long as they're different, I think, just to show that they are different odd numbers here. Okay, so we want to do the product of them. Okay, so the product means to times them, yeah? So 2k plus 1, I want to times it by this. Now, of course, when you're timesing this by this, you're best off straight away to use a bracket, aren't you? Okay, because if you write times, it just looks a bit strange, right? So if you put bracket to show you're going to times this by this, you know then the process. So let's expand this bracket here. Let's multiply out. So I've got first 2k times 2p is 4kp. Okay. Yeah, 2 times 2 is 4 kp, and then the outers is 2k, because 2k times 1. The inners, 1 times 2p is 2p, and then the lasts, then 1 times 1 is 1. So I've got that there. And you'll notice here that we can't actually simplify that any further, okay? Because they're all different terms, aren't they? That's a kp, that's a k, that's a p, and then you've got a constant at the end. What we can try and do is try and factorize like we did before, okay? And in this case, we can't factorize the whole thing, okay? Because, you know, we were looking for 2 before, weren't we? Okay, now 2 is a common factor of the first 3 terms, but of course 2 doesn't go into 1. So what I'm going to do here, I'm just going to factorize the first 3 terms. I'm going to take 2 out, okay? So if I take 2 out, I've got 2 then times 2kp plus 2 times k, yeah, will give me that, and then plus 2 times p will give me 2p. So factorize the first 3 terms. Don't forget to add that 1 at the end. And what I want you to notice is then, right, is that this setup here is similar, okay, in fact identical to our sort of understanding of odd numbers. So if you go back to this, what we did at the start here, odd numbers are of this form here, 2n plus 1. Well, if you think of that as just like a number, because it will be a number, won't it? Okay, that would work out to be some sort of a number. Okay, well, you've got it times it by 2 then, and you're adding 1, so that means it's odd. Okay, straight away it's odd because it's of the form 2n plus 1. Okay, n is just that there, yeah, for whatever number that comes to, but it's of that form where we're adding 1 on to this here. The other way of thinking about it here clearly is, think about this here. This is even, isn't it? Just this bit here, this is even because it's a multiple of 2. Okay, so this bit's even. Now when you add 1 to it, when you add 1 to an even number, you get an odd number.